How a subnet mask works. The witty way. You are the camp counselor at a kids' camp. It is a fun weekend for the kids to play and try different activities. You retrieve the sign-up sheets for today's activities and you see this. It is the latest in the kids' trends and you have no idea what it means. You take a look at the master roster in an effort to decipher this code, but it offers no help. Is it Ren Jones or is it Ezra John who's supposed to go hiking? Commence crash out. The kids decide to offer you clues to join in their fun. One kid says, I'm Jonezrin/3. And the other kid says, I'm Jonezrin/5. They explain that the key is to count, starting from the left, the number provided with the name. You determine the kid whose name is Jonezrin/3 is actually Ezra John. And the kid whose name was Jonezrin/5 is Ren Jones. You are now able to successfully decipher all the children's names. This trend the kids thought they were clever enough to design is how subnet masks work. Let's check it out with some computers. The computers here have been assigned their IP addresses. The new inventory has been released. The computers in the 10.1 network are on the first floor, and the computers in the 10.1.0 network are assigned to the second. There's a problem though. How do the computers know which network they belong to? It's easy. They use the same trend as the children, but in the context of computing, it's known as subnetting. Let's try an example. We have a computer with the IP of 10.1.1.3 with a CIDR of 16. We first convert the IP from dotted decimal to binary. With the CIDR of 16, this is what the subnet mask looks like in dotted decimal as well as in binary. The subnet mask is compared to the IP to reveal which bits are part of the network. In this case, either the 10.1 network or the 10.1.1 network. The on bits in the subnet mask correspond to the network portions of the IP address. Here is a human-friendly example to make it make sense. On the stage, we have our IP address, but we only want to see the network portion. For that, we will need the lights, which will serve the same purpose as a subnet mask. Recall that we had a CIDR of 16. This means that the subnet mask will have 16 bits on. The show has now begun, and the lights are revealing which portions of the IP are part of the network. The host portions of the IP remain hidden in the darkness of the stage. Here you see that the illuminated portion of the IP is the first and second octet, the first octet representing 10 and the second representing 1. It turns out that the computer with an IP of 10.1.1.3 and a CIDR of 16 belongs to the 10.1 network.